13. We're going to try to go really fast on these. Are we recording? So we can get as many of these done as possible. You also probably want to have your macro pulled up so you can get a Desmos as needed, okay? Sure, ranger, 2 identical corrals, 100 feet of fencing. So we need to have an X and a Y. So I'll call we'll call this one more time, please. It's not right. Going over here. That's X. That's Y. 100 feet of fencing. X, 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 Y, Y, Y. So 4X plus 3Y equals 100. We want the largest possible area. So the area is going to be this region plus that region. So 2 times, so 2 of them, X times Y. I want to minimize, or in this case maximize the area, but there's 2 variables right there. So I'll modify that equation to Y equals, subtract 4X from both sides, 100 minus 4X, divide both sides by 3. Yes?
Did I ask you a favor?
You can go in there, it's unlocked.
It's unlocked?
Yep.
Oh, okay, good. I thought y'all closed it up already. Sorry.
So, alright, 100 over 3 minus 4/3 X. So we'll take that value and substitute it in for Y. So area equals 2X times 100 over 3 minus 4X over 3. You know, I might just write this. 100 minus 4X all over 3. I'm not writing anything else after this. I'm typing this into Desmos. And I'm going to find out where that maximum area is and we'll figure out what X is. So here we go. I recommend that you do this as well to make sure that you can 2X times divided by 100 minus 4X all over 3. Is it not? 2X, parentheses, divided by 100. Got something wrong here? Oh, it's just right down there. There you go. That look good?
Mm-hmm.
So, what does that ordered pair tell me, class?
It says the maximum area, or yeah, would be 12.5.
The maximum area is not 12.5. That is so.
It's the maximum
Dimension.
Yeah, so 12.5, comma 416.667. This is the X value, which gives me an area of this.
Oh, that's right.
Okay, that's because
It's like the box.
This is the Y equals. You know, if Y equals, so it's the area equals. So I have a Y value of 416.66. That's the area. Okay. So X is my X value. This is the X value, which will give me the maximum area. So 12.5 is my X. And then in order to find Y, I will just take 12.5 and plug it into this formula right here. So 100 over 3 minus 4 times 12.5 over 3 for a Y value. Anybody have a number on that one?
Let's see.
You could also just key that also in the Desmos. I believe it's 16.7, 16.666.
4 times 12.5.
Yeah,
Yeah, so
but it's 2/3.
16 2/3.
Mm-hmm.
So, all right. So So there's your other number. This is how you find y based on this equation right here. Okay? If you're not sure about what we did, it's recorded. We'll post that later today. Jeremy, give me one more.
How about,
Wait,
Go ahead.
on the paper, it's like one length by the other
Yeah.
length, so why would you not multiply x by 2 to get rid of it?
Ooh, good question. Yes, we didn't label that. Okay. In that case, I guess it depends on how you have it labeled. So, I'm a couple of you had double the 12, right? Okay, well, if that's the case, we can go back and put a little note on your answer sheet. I can give you points back. If you had, was it 25? If you had 25 by 16.7, and I'm assuming that that's because you put this whole region, that was your x.
Well, I had 2 x's with 1 x and then 1 x.
Yeah.
So when we solve for x,
Okay, well, I
So
guess
get
this is,
the-
well, okay, I'll counter that with it says, what dimension should the rancher use to construct each corral?
oh, each.
Okay,
Yeah.
so, there you go, so, my answer's right. Your grade stands, you can rest in the fact that you did the correct process, but, the question is physically asking what should the dimensions of each corral be? So, hey, you'll get it right tomorrow too. Jeremy, give me another question. Alright, let's go 5.
oh yeah.
Okay, find each limit using L'Hopital's rule. So, the way that we solve these is we set them equal to y. I'm not sure, oh, it's not. Smarty isn't running for some reason. So we set y equal to the limit as t approaches 0 of t plus 1 to the 1 over t. Pretty much anytime you had the variable in the exponent position, that's what we did. You set a y equal that, and then you took the natural log of both sides. Natural log of y equals the natural log of the limit, blah, 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 you know. And the reason is we saw that the natural log of limit is equal to the limit of the natural log. So we'll say the natural log, and then we put open parentheses, t plus 1 to 1 over t. And the reason why we do that is because when you have the natural log, you can use the properties of pulling that exponent down. So natural log of y equals the limit as t approaches 0 of 1 over t times the natural log of t plus 1. So if you want to, we could write that as the limit as t approaches 0 of natural log t plus 1 over t. If you plug this in your calculator, you'll find that that's the natural log of, if you plug in 0, you have 0 plus 1, natural log of 1 is 0, and so you have 0 in the numerator as t approaches 0, then 0, so it's 0 over 0, so we can apply L'Hopital's rule. So that's going to be the limit ln y is the limit as t approaches 0 of the derivative of the numerator over the derivative of the denominator. Derivative of the numerator is 1 over t plus 1, because derivative of natural log is 1 over and whatever's inside there, times the derivative of the inside. Derivative of t plus 1 is just 1. The derivative of the denominator is just going to be 1. And this side we have ln y equals, we can do direct substitution at this point. 1 over 0 plus 1 times 1 over 1. So that's ln y equals 1 over 1, which is 1. That's not the answer, that's the natural log of the answer. So to convert this back into an exponential equation, we would say e to the 1 equals y. So E is your answer, which is 2.718. So if you have that, then you're good to go. Okay, as you can tell, we got to be kind of quick on these.
So, could you repeat again how you go from the e to the 1, e equals y?
This to this?
Yes.
Sure. The natural log of x equals c. What that means is log base e of x equals c. Log base e. That's what natural log means.
Yes.
Natural log means log base e. Okay? This, via precalculus, means e to the c equals x. That's what log means. Logarithm is a way of saying take this base to this exponent and you get this number. It just rearranges them for different purposes.
Okay, so whatever number you get, that's the number that you raise e to get y.
That's a way of thinking about it.
Okay.
I would not. I mean, I would put it differently, but sure. I mean, I would say use the property of logarithms. Oh, I know. All right. Think about the next problem. Rosa, you're up.
11.
Find the equation change line. Yeah, a lot of people miss this, didn't feel like you really needed to. Okay? And we want to convert it into y equals mx plus b form. Okay? So, this is why you need to have the point slope formula memorized. Y minus y1 equals m parentheses x minus x1. Find the slope, the equation of the tangent line at the point 3, 1. So that's right here. We should have something that's going to look kind of like that. We already have an x1, we already have a y1, so we're 2/3 of the way there. So y minus 1 equals the slope, we don't know what that is quite yet, times x minus 3. Is this ringing a bell for anybody? Good. How do we find the slope of the tangent line of that equation?
Well, the slope of the tangent line is the derivative, so you take the derivative and then you plug in the y.
Plug in the x.
Or the x, yeah, not the y.
So, all right, slope of the tangent line evaluated at 3. Well, that means, okay, so let's find the derivative. I'll say it's the y prime evaluated at 3. So, side problem over here. So, y prime equals negative 3x squared plus 6x. So, y prime evaluated at 3 means negative 3 times 3 squared plus 6 times 3. So 3 times 3 is 9 times negative 3, so it's negative 27 plus 18. So negative 9.
Yep.
So y minus 1 equals negative 9 times x minus 3. We'll distribute that. Negative 9, so we have negative 9x. A negative times a negative is positive, 27. And then I'm adding 1 to both sides, so y equals 27, y, negative 9x plus 27 plus 1, so that becomes a 28. Negative 9x plus 28. Rosa, do you have another question for us?
No.
Alright. Nick, your choice. While you're looking, Ivan, you're next, so if you're thinking of another problem you want us to work on. Well, sure. All right. We should be experts at this, right? Supermarket wants to construct the box. It's a 16 by 30. All right, it's got to cut out squares. Okay, I'm going to say that that's going to be X. So if he cuts out X, then this would be X, then this would be X, and X, and everything's X is cutting out everywhere. Okay, so we know that the volume is equal to the length times the width times the height. We'll say the length is this whole entire section. So that's going to be 30 minus 2x. That cut out an x here and I cut out an x here. You all agree with that?
Mm-hmm.
The width is going to be 16 minus 2x. The chunk there. And the height, when we fold this up, is going to be x. Let's plug that into Desmos and I'll do that with you and then we'll see what the answer is. Are you serious? That's all we had to do? Yep. But I know that sometimes plugging it into Desmos you get a weird thing. That's why Goddard gave us mouse with the wheel. Oh, you don't have a mouse wheel? Alright, bring a mouse tomorrow with a scroll wheel so you can do the scrolly game. Let's do y equals good old 30 minus 2x, 16 minus 2x, and an x. So you can go without your fingers slipping because you have dry fingers because it's winter time almost. Whoa, really? Did we type this in right?
Yes. It's really
It's
tiny.
like not that long of this.
It keeps going up higher there. Oh yeah, this might be a good time to kind of think about the boundaries. That obviously I can't have anything bigger. I need to be kind of looking. You know, I can't pull more than 15, right? Or 15 on either side, so that 2x needs to be kind of small. You're telling me this is a crazy high parabola kind of thing?
A little further up.
Ready to go up a little bit
It's
farther?
right there.
Oh, there it is. Okay. I guess knowing the shape of it kind of helps. In case you can't tell by my fast zooming, what it looks like is and it goes really high. We know that because there's an x times an x times an x, which makes it a cubic, and we know what a cubic looks like. This looks like 3 1/3. So we have ordered pair 3.33 repeated, comma 725.926. Now what does that correspond to? That corresponds to an x, and that corresponds to the y, which in this case is the v. So x equals 3.33. That corresponds to the x that I would cut out. So, yep, the answer was 3.33. Thanks, Nick. Ivan, your turn.
Alright. Could we go over number 2?
Okay. Plug in 0. We would have sine of 0 over 0. The sine of 0, as we all know, is 0, so that's a 0 over 0 situation. So, L'Hopital's rule says, let's take the derivative. Take the derivative of the numerator. Derivative of sine is cosine. Chain rule times derivative of the inside, 5. Derivative of the denominator is 3. Now I'm going to plug in 0. I have cosine of 0, or cosine of 5 times 0, so cosine of 0. Anybody know off the top of their head what's the cosine of 0? 1. Right. So now we have 1 times 5 over 3. So that's 5 over 3. L'Hopital's rule says because I get a concrete definitive answer for this limit, then that's the answer to that one. So the answer is 5/3.
Okay. I don't know why, but I put 1/3 for some reason. So.
1/3 was the answer number 1.
Yeah.
So maybe got those transcribed. I don't know.
Because I have the exact work right here, and then I just put 1/3 at the end.
Oh,
I don't
okay.
know.
Yeah. Maybe did you not do chain rule?
Maybe I forgot to multiply by 5. I don't know.
Yeah. Okay. Do you have another one for us, Ivan?
Sure. I guess. Let's see. I might know how to do this one, but number 14.
Sure. So same kind of thing. We're going to call this x, and we're going to call that y. I'm not gonna read the problem to you because you read it and looked at it and sweated over it yesterday. Hopefully you got to this point. I don't know. You did for homework at least. Alright, he's got 300 feet of fencing, so that means 300 is 2, when I'm calling 2x plus y. And he wants to have maximized area. Well, area is equal to x times y. I need to get this area in terms of a single variable, so I'll rearrange this equation so that I have y equals 300 minus 2x. Substitute that value in here, so area equals x times 300 minus 2x. I'm not writing anything else on my paper. If I've got access to Desmos, I'm not even going to simplify that equation. Desmos doesn't care; it can do the work. 300 minus 2x is going to maximize that equation. Hardest part here is just turning that word problem into a equation. Y equals x, 300 minus 2x. I know it's going to be some sort of parabola. And there it is, really narrow, but we've got it. $75. That's an ordered pair. 75, comma 11250. That corresponds to the x. That corresponds to the area at its maximal value. Okay. So I've got an x value of 75. I'll go back here and I'll plug that 75 in to figure out what my y value is. So y equals 300 minus 2 times 75. I can do that with my head. 2 times 75 is 150. 300 minus 150 is 150. So y equals 150. 75 and 150. Now I've done this and I'm a teacher and I'm trying to work fast so we get on it. So I wouldn't expect you to work this fast during the test.
You'd be done really quick.
But I'm you know, so just understand my expectations. All right, thank you, Ivan. Cody, question.
Number 4.
All right. So secant s minus 3 secant minus 3 tangent. If you remember, one of the techniques that we had for these problems, since pi over 2, and you're like, oh, I'm not sure what pi over 2 is, where it is on the calculator, stuff like that. Well, or where these graphs are. Okay, well, maybe that's a little on me for, I should be forcing you to memorize these things and holding you accountable for that. But in the meantime, we're going to assume this is probably going to be like an infinity minus infinity, or 0 minus 0, or something like that, or infinity minus 0, I don't know. But either way, it's on a question section dealing with L'Hopital's rule. We probably need to turn it into fraction to get it into L'Hopital friendly version. So I'm going to turn secant into 1 over cosine. And I'm going to turn tangent into sine over cosine. So that's not too bad. I have a common denominator. So 3 minus 3 sine s over cosine s. That's pi over 2. Pi over 2, the value is 1. So 3 minus 3 times 1, so that's 0. And cosine, that's pi over 2. 0. So this is a 0 over 0 situation. Let's take the derivative of the numerator and the denominator. Derivative of 3 is 0, so we have minus 3 cosine s. The derivative of cosine is negative sine. So the limit as s approaches pi over 2. I I mean, I have these memorized, and like once again, maybe I should force you all to do that and hold you accountable to it. But even if you don't, you have a calculator, you can put in radian mode. You've got Desmos, you can put in radian mode. If you don't know how to put in radian mode, you go over here and hit the little wrench, and then you go down to radian mode. But I don't need a calculator, I'm going to just plug in pi over 2, so it's going to be -3 cosine pi over 2, that was 0, sine of pi over 2, 1, so 0 over 1 is just 0. So answer number 4 is 0. Good stuff. Cody, you got another one for us? Emily, you be thinking, and Stephanie Hecker, if I get one from everybody.
Guess 3.
Number 3. Okay. So this is, as r approaches 0, we have a 0 here and an LNR. It's not, as is right now, it's not a L'Hopital's rule numerator and denominator. So what we'll do is, we'll take that 3r, we'll take the r squared, and we'll shove it down in the denominator. But when you put it down in the denominator, it becomes r to the -2, or you can put it like that, 1 over r squared. So we've got 3, and we've got ln r. If you remember, natural log just continually grows. It grows, eventually it gets to infinity. It takes a long time to get there, but this is hold on. Natural log. Yeah, that is what happens as it approaches infinity, but as it approaches 0, it approaches negative infinity. So this is a negative infinity, and then 1 over r squared is 1 over a smaller and smaller number, so it's going to be a larger and larger number, so that's infinity. So it's infinity over infinity, so you got a L'Hopital's rule situation, works out. Let's just go and take the derivative. So derivative 3 times ln r is 3 times 1 over r, and this was r to the -2, so taking the derivative of that is going to be -2 times r to the -3. This is the limit as r approaches 0 from the right. So the limit as r approaches 0 from the right. Let's see what we've got here. So I've got 3 times 1 over r divided by -2. R to the -3, I could put that up in the numerator and put it as r to the positive 3. I mean, I could write it as 1 over here, but the point is that this is going to end up doing some canceling out. This is pretty nice that r cubed up there will cancel out that r, and so I have an r squared. And so now I have limit as r approaches 0 from the right of 3r squared over -2. And plugging in the 0, I just have 0 in the numerator over -2, so that's 0. And so limit of this equals 0, which means limit of that also equals 0. So I think for this one, number 3, yeah, the answer was also 0 on number 3. How about that? But that's what we found out in L'Hopital's rule too, I think. We added that homework L'Hopital's rule. You had a sort of an unfair or uncharacteristically heavy number of zeros for answers. There are other ways of doing these, pre-calculus ways of doing these problems, which I can share with you at 35. Emily, you're up.
Number 10.
Number 10. Find the x-coordinates of all points of inflection in the open intervals of the function concave up and concave down. What I'll probably do for tomorrow's quiz is I will shorten it up. I feel like the quiz was a little long. I don't know. That was my gut feel. But I wasn't around for y'all to finish it. Was it rather lengthy?
It wasn't as long as I expected whenever you said it was going to be really long.
Okay. For honestly, this is sort of selfish, but for grading purposes, I don't really need to know that you know the inflection points and the concavity points. I'll probably just pick one of those. I'll say because if you can find one, if you know where it's concave up, then logically you know where it's concave down, and logically you know where the inflection point is. Not necessarily, but I mean, if you get one of them wrong, you get all three of those wrong. So I might as well just tell you just find one of them. But for our purposes, we'll find all of those. So first derivative or second derivative tells us about inflection points in concavity. Second derivative. Somebody find second derivative. F prime is negative 3x squared plus 4x. F double prime is negative 6x plus 4. I'll go ahead and find where that equals 0. So give me some of my breakpoints. I'll say that equals 0. And so x is going to equal, I'll pull that negative 4, so I've got a negative 4, and then divide both sides by negative 6. So negative 4 over 6 is 2 over 3. So that tells me that I have 2/3 is an interesting point, possibly an inflection point. I'll pick a point to the left of that, I'll say 0. I need to pick a point to the right of that, I'll say 1. 0, when I'm plugging this in, to be clear, this is the second derivative, sign chart. Plugging it in over here, that term goes to 0, I just have a 4. When I plug in 1, I have negative 6 times 1, so I'm at negative 6 plus 4, so negative 2. So I don't know why I put a 4 right there, plus. Positive, negative. So this tells me that in this region on the original function, I'm concave up. In this region over here, I'm concave down. So the concave up region is from negative infinity up to 2/3. The concave down is from 2/3 up to infinity. And the inflection point is at x equals 2/3. So it's basketball season, tournament time. I don't know if y'all ever watch much basketball, or at least you've been to probably a game, right? Maybe several. Coach Hill does something really great. All coaches do this, but I always see this with Coach Hill, so I'll use him as a good example. Anybody ever notice, maybe you should have had any other basketball games, something like that, the player, he does something, makes a bonehead mistake, goes for a left-hand layup, but uses his right arm, like that, Like he does something crazy, right? Or doesn't, block out, or doesn't do something like that, right? Coach gets mad. Subs him. What does he do immediately? What's the first thing? Before that kid sits down, before that player sits down,
He starts talking to somebody else.
he starts. What is? Coach Hill will talk to somebody else. But he talks to him, right? Before, I don't know if you ever see that, but when the kid comes off, out the line, he's there and he's telling him exactly what's going on, or what he did wrong, and he's doing that correction immediately. Okay, and the idea is you do it while it's still fresh in your mind. And this is just how learning occurs. Is you identify the things that this is what you did and this is what you need to do instead of that. Okay, and that's great. That's how you correct. That's how you coach. That's how you teach. That's how you learn. So what you need to think about is, what did I do wrong on maybe not this particular problem, but on whatever. Identify your thought processes. Identify what was missing or what you didn't know. If you can, name it, because if you can name it, then you are like total boss and owner of that particular process or that thought. And then you can say, oh, I didn't label the sides on the rectangle, because if I label the sides, then I could create the formula, then I could, so on and so forth. So anyway, label it, correct it, fix it right now. That's why I wanted to make sure that we spent today doing this and tomorrow doing the retake. Stephanie, you're up.
Number 1.
Number 1. So if we plug in, just do direct substitution, -5 plus 5, that's going to give us 0 right here. And then plug in -5, that's going to be 25 plus a 7 times the -5 is going to be a -35 plus a 10. That all cancels out to 0. So we have a 0 over 0 situation. L'Hopital's rule applies. So we have the limit as t approaches -5. There is a negative out in front of there, but -0, 0 is still 0. So Or it's still a zero to zero situation. So I'm just gonna leave that negative out front there, taking the derivative, because we can treat it as a constant multiple. Remember, if you have a number times a function, you're taking the derivative, it's still that number times the derivative. So the t plus 5, the derivative of that is just gonna be 1. Because derivative of 5 is 0. And the derivative denominator, 2t plus 7. And now let's go ahead and try our direct substitution. So negative 1 over 2 times negative 5 plus 7. So 2 times negative 5 is negative 10. So plus 7 is negative 3. So negative 1 over negative 3 equals positive 1 over positive 3. All right. We'll try to make sure we talk to at least everybody once. Hector, question.
Number 9.
I know at some point we're probably gonna get some that y'all are like, I already know how to do that one. I got it right. But that's what I'm seeing what's going on. Okay. Final points of relative minima and maxima. If none exist, write none. Okay. All right. So if you remember, points of relative max and min can occur at critical points. Okay. Critical points are where the derivative equals 0 or where the derivative doesn't exist. So let's take the derivative of this. I'm open to suggestions. Do y'all want to go quotient rule on this, or do you want to pull that x squared minus 9 up to the numerator? Well, as I say that, we're gonna need the quotient rule on this. Let's just go quotient rule on this. So I'm gonna stash that negative up there in the numerator. So it's negative 2 over x squared minus 9. Low d high minus high d low. So low x squared minus 9. D high, well that's just 0. Minus high, so negative 2. D low, 2x plus minus 0, but that's goes away. Over low squared we go. X squared minus 9. That term was 0. Negative negative is positive, so I have 4x over x squared minus 9. So far so good? Squared. I'm interested in places where the numerator, where this either equals 0 or doesn't exist. Well, that occurs when the numerator equals 0 and the denominator equals 0. The numerator, 4x equals 0 when x equals 0. The denominator, x squared minus 9 squared equals 0. Well, I'll take the square root and I'd have x squared minus 9 equals 0. Add 9 to both sides, I end up with x, excuse me, x squared equals 9.
So square root 9.
Square root 9 plus or minus 3. So x equals plus or minus 3. So negative 3, 0, and positive 3. Those are my options. And I want to pick a number here, 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 and here if I'm going to find any relative max and relative min. Okay? I'm going to, so you could plug in numbers. I'm gonna write so here 4x over x squared minus 9. That's my first derivative. Just reproducing that. Negative 3, 0, positive 3. I'll pick negative 5, negative 1, 1, and 5. And I've got a calculator, so I'm just gonna type that into the calculator. You got time? So I'm plugging in the derivative, y equals 4x over x squared minus 9 squared. That look all right? There we go. All right. Negative 5. So this is the derivative, and I'm just looking at this positive, negative. Clearly below the x-axis, so that's negative. At negative 1, still negative. At 0, after 0, so in this region right here, we're positive. And then we're also positive.
So negative.
So we see that we've transitioned from negative to positive. So that would mean that since f prime, the original function goes from decreasing to increasing. So that's a relative min. Relative maximum?
Does not exist.
None. Okay. There we go. One for everybody. You can take that home. I'll try to post this video shortly. And hopefully get Chloe back up in here. So, when you walk in tomorrow, there'll be a new quiz. I'll take the best of the two. If you're satisfied.